This voice you're hearing from us, it's original, made with an open-source TTS model.
It's not Yukkuri, and it's not Zundamon. I always pictured voice cloning as recording for hours and hours to train a model.
These days you don't even need training. You can make one from a short clip. And no cloud fees either. This time, this one's for anyone who wants to make an original voice character too. We generated our voices with 8 of the latest open-source TTS models. We had them read Japanese and English and compared the results, so let's get into it. We compared 4 things: how well it reads Japanese, how close the voice sounds, generation speed, and the number of supported languages.
So it's not just about how well it reads out loud.
Once you're actually using it day to day, the differences show up elsewhere. We make our videos with this voice every single day. And the thing we've been dealing with the whole time is this gacha-like behavior. Ask for the same voice, and sometimes a totally different person comes out.
Yeah, even my voice gets re-rolled until we land on a good one.
Right. So we've worked out our own way to cut down on the misses, and to weed out the ones that slip through. We do a bit of prep before generating, plus a check afterward.
And we'll tell you which model we'd recommend if you're making a voice character right now.
First, let's start with how voice cloning actually creates a voice. You give it a base voice sample, and the model mimics that voice quality to read out whatever text you want.
What kind of voice data do you need for that? Do you need hours and hours of it?
My first recommendation is your own voice. Or ask a friend or family member to record one for you. It doesn't need to be long. Just remove the noise and level out the volume. And that's enough for a bass.
Can't I just use a voice actor I like?
Using a voice you found online without permission is a rights violation. You can only use voices you actually have permission for. Here are the 8 we tried this time. Q13 TTS, OmniVoice, Fish Speech, Chatterbox, CosyVoice, GPT-SoVITS, F5 TTS, XTTS, all 8 officially claim to support Japanese. We kept the conditions matched, same machine, same voice data, same script. Then we generated audio in both Japanese and English. The key thing is whether it can correctly read the alphabet and kanji. Let's listen right away. First up, Chatterbox. 皆さん今日はAI の進化って本当にすごいよね。今日も一日頑張ろう。
Whoa, the voice quality itself isn't bad, but it read Kanishiwa as Kaiwa?
It makes a lot of misreadings, which is a shame, because it's close.
And didn't you hear some weird ambient noise between sentences?
Yeah, I'm guessing some noisy audio slipped into the training data. Next, CosyVoice. 皆さんこんにちは。AI の進歩で今度にすごいよね。12も一日頑張ろう。
The voice is close, but the pronunciation sounds like Chinese. And there's some nasty noise at the start too.
This is the pattern where the voice quality matches, but the Japanese is broken. If you pick based on voice similarity alone, you'll get burned. Let's check out another one. F5 TTS. 皆さんこんは。AI のって1にすごいよね。2も11も。
This one reads like Chinese too, and the audio clipping is pretty rough.
Let's move on. GPT-SoVITS. 皆さんこんにちは。AI の進化って本当にすごいよね。今日も一日頑張ろう。
The reading is correct, but it doesn't quite sound like Renka, does it?
This one turns into a different person practically every time you generate it. The variance is way bigger than with the other models. Last one, XTTS. 皆さんこんにちは。AI の進化って本当にすごいよね。今日も一日頑張ろう。
This sounds like an old-school robotic voice.
Development on XTTS has been stalled for about 2 years, so there's not much reason to pick it now. So even if it says Japanese is supported, that doesn't mean it'll actually sound good. These 5 fell short. That leaves 3. Q13 TTS, OmniVoice, and Fish Speech. All 3 sounded pretty decent. Alright, let's listen to the remaining 3. First, Q13 TTS. 皆さんこんにちは。 AI の進化って本当にすごいよね。今日も一日頑張ろう。
Wait, this is just Renka's usual voice.
Next, OmniVoice. Let's try Shari's voice too.
皆さんこんにちは。AI の進化って本当にすごいよね。今日も一日頑張ろう。
Last, Fish speech. 皆さんこんにちは。AI の進化って本当にすごいよね。今日も一日頑張ろう。
At this point, any of them sound like they'd work.
Both the voice match and the Japanese felt usable at a practical level for all three. That said, they're not perfect. Katakana words like AI get mispronounced, and the intonation is off here and there.
Can't that be fixed with some tuning?
You can fix it if you really push, but it's a lot of work. I think that's true for Zundamon and Yukkuri too. Also, Japanese seems to have less training data than English, and that's probably a factor too.
So English is what it's actually good at.
Here's what OmniVoice sounds like in English.
Hi everyone. The way AI keeps evolving is honestly incredible. Let's make the most of today.
Even in English, that's definitely still my voice.
All three are pretty fluent in English too. Beyond the voice itself, generation speed is one clear difference. Speed depends on the environment you run it on. So we measured everything on the same AWS GPU machine, a G6X large. To generate one line, OmniVoice takes under a second. Qwen3 TTS takes about 10 seconds. Fish speech takes 3 minutes.
3 minutes? If that's just for one line, wouldn't that be a pain for a whole video?
If you generate all the lines for a full video, that adds up to hours just for generation. Next is the number of supported languages, and this differs by an order of magnitude. OmniVoice supports over 600, Fish speech over 80, and Qwen3 TTS supports 10.
That seems like it'd matter a lot if you want to go multilingual.
On the other hand, if you only need Japanese and English, Qwen3 TTS's 10 languages are plenty. Last is the terms of use, and all three differ here too. OmniVoice's official terms explicitly ban voice cloning without consent. Fish speech is under a research license, so commercial use isn't allowed. Qwen3 TTS has the most permissive terms of the three.
So even if the code is open source, there are still conditions on how you use the model.
If you only skim the license file, it's easy to miss these usage terms, so watch out for that. Speed, language support, terms of use. Which one you prioritize changes which one you'd pick. Whichever of these three you pick, there's one thing you'll have to deal with, the gacha. The voice data, the script, and the settings are all the same, but a different voice comes out every time you generate.
Why does the same input produce something different each time?
It's because TTS is generative AI too. Same as how a chat AI gives a different answer each time you ask the same question. Internally, it's making probabilistic choices. Let's actually listen to some misfires. First, the pattern where a totally different voice comes out.
皆さんこんにちは。AI の進化って本当にすごいよね。今日も一日頑張ろう。
You did pass Renka's voice as the reference for cloning, right?
Yeah, it was generated with that reference properly.
But that voice just now wasn't Renka or me. It was some stranger.
Next, the pattern where only the beginning breaks.
皆さんこんにちは。AI の進化って本当にすごいよね。今日も一日頑張ろう。
There was this sharp intake of breath right at the start.
That opening noise shows up in different forms. Sometimes a breath, sometimes doubled audio, sometimes clipping. Then there's the pattern where the gender changes.
Hi everyone. The way AI keeps evolving is honestly incredible.
Let's make the most of today.
It starts off sounding like a man.
That was an English example, but it happens in Japanese too. Last, the pattern where the reading itself breaks down.
皆さんこんにちは。AI の進化って本当にすごいよね。今日も一日頑張ろう。
Minasan came out as Minasasan.
None of these are configuration mistakes. They just show up occasionally under the exact same settings.
If you want to use it as one consistent character voice, like for a video, that's a real problem.
Separate from misfires, there's also the issue of misreadings in Japanese. This one isn't about the gacha. It's determined by how you write things. In Japanese, The same characters can have multiple readings, right? Take Chinese letter. It can be read hitom or ikimoku. If you write the number 1 followed by Chinese letter, it can be read as tsuatachi or ikinishi.
So humans unconsciously figure out the right reading from context.
In this test, we wrote 1 Chinese letter in a sentence meant to be read as ikinishi. And every model we tried read it as tsuatachi anyway.
I really wish it could pick that up from context.
Also, when we wrote ai in Roman letters, some models misread it. They read it as the Japanese word ai, meaning love, or even as the name Aya.
So Ai's evolution is amazing turns into love's evolution is amazing.
When it comes to reading kanji correctly, you should assume today's TTS is worse than an elementary schooler. Assuming it won't pick up on context, we adjust how we write things instead. The basic fix is to rewrite it in katakana or hiragana. Write ai out phonetically instead, as I, like spelling it out, and it reads correctly. That said, doing that does make the intonation a bit off. For now, we've just accepted that. For our videos, we keep a pronunciation dictionary of words that tend to get misread. We run the script through it before handing it off to the model. A lot of technical terms are proper nouns, so they're easy to misread as is. The dictionary locks in the correct reading for those.
I wonder if we'll ever get to a point where it nails both the readings and the intonation perfectly.
When you're generating audio at scale, there are days the whole machine just goes down. This is the thing that's hit us hardest running Q13 TTS in production, running out of memory.
Wait, not just a failed generation, the actual machine.
Yeah, exactly. There are a few causes. Sometimes generation just doesn't stop and runs away. Other times, after running for a long stretch, memory that was used never gets released. It just keeps piling up. There were also cases where a process that should have finished stuck around in the background. It kept holding onto memory. It sometimes ignores the shutdown command and just stays alive. Before we knew it, a bunch of these had piled up and eaten through all the memory. Each individual generation looks totally normal. It's only once we start mass producing that this shows up. So we set a hard cap on generation time and always cut it off. And we monitor memory usage. If it starts ballooning, we rebuild the process. Doing all this is a lot of work, so if you're just starting out, VoiceBox is an option worth considering. It's a desktop app that bundles multiple TTS engines into one. It's getting attention because you can build a voice profile with just a few clicks. It includes Q13 TTS and Chatterbox, which we tested this time. You can also pick engines like Tada and Kokoro. It's not a TTS model itself, it's a UI for operating models. You can switch between engines and try them out. Let me talk about what we do to cut down on misfires. For the ones where the opening breaks, apparently it's linked to how the reference audio ends. The reference audio can cut off abruptly in the middle of a word. When that happens, the continuation of that sound can supposedly bleed into the start of the generated audio. So the first step is adding a short silence to the end of the reference audio. Even that doesn't fully get rid of the noise at the start, so we also changed how we generate it. We attach dummy words before and after the actual text when generating. For example, if the actual line is "Hi everyone," what we feed the model is "Hi everyone,
But then the finished audio actually says doesn't it?
It does. What we get first is audio with an extra tacked onto the start and the end. That fragile opening gets absorbed by that throwaway instead of the real content. After that, we run the audio through Whisper. Whisper is the open source transcription I released. It doesn't just transcribe the text, it also gives you the start and end time for each word, the time the opening ends, and the time the closing begins. Cut at those points, and only the actual content is left. We smooth out the cut points with a short fade, so it doesn't sound abrupt.
Can the dummy word be literally anything?
Surprisingly, this part is actually tricky. At first, we used N as the Japanese dummy, but the model kept pronouncing it as un. That mismatch with the transcript meant we couldn't detect it. When we tried for English, Whisper wouldn't transcribe it at all this time. So again, we couldn't get the position. Something that's pronounced clearly reliably transcribed and short. We hunted for a word that met all three conditions, language by language. We landed on un for Japanese and yes for English. There were also fixes that just didn't work out. We tried detecting silent gaps and cutting there, and also cutting based on volume changes. The noise can end up stuck right up against the actual content. When that happens, it ends up chopping off the start of the real audio too. That covers what we can do before generation. Even with all these fixes in place, misfires don't disappear entirely. About 10% still slip through. For a 10-minute video, we generate somewhere around 150 to 200 lines. If 10% slips through, that works out to somewhere in the teens of misfires per video.
Finding a dozen plus of those just by ear sounds rough.
That's why we built a system that catches and discards misfires automatically. The one doing the most work is cross-checking against Whisper's transcription. We transcribe the generated audio and compare it to the original text. Misreadings and missing openings both get caught this way automatically. When comparing, we don't check for exact character matches. We convert both sides to their reading first. Even if it's transcribed as the kanji Chinese letter, Japanese letter, it counts as correct as long as it reads as minasan.
But that wouldn't catch the ones where the voice turns into someone else entirely, right?
Right. Even with a different voice, the sentence is still read correctly. So the transcription comes back with a perfect score. So we tried to get a machine to judge the voice quality too, and tested a bunch of things. There are metrics that score audio quality, and metrics that measure voice similarity. Neither one turned out to be usable. The quality score had nothing to do with whether the voice was a different person. Sometimes the misfires even scored higher. The similarity metric wasn't any better either. The scores for good and bad takes overlapped too much to draw a clean line.
Funny how something with such a convincing name turns out to be unreliable.
Only one approach actually ended up working. We keep a collection of known good audio. Then we check how acoustically far a new clip is from that collection. If it's too far off, we flag it as a suspected misfire. We use that judgment to run generation in an automatic loop. Generate, judge, and redo it if it fails. Each candidate gets a score, and the moment one clears the threshold, it's adopted right away. It still might not hit the threshold after a set number of retries. When that happens, we go with whichever candidate scored the best.
So even if it doesn't quite clear the bar, that beats ending up with no audio at all.
Exactly, but we flag that audio and manage it separately from the ones that passed normally. Also, this threshold has to be rebuilt for each language. You might reuse the Japanese threshold for English or Korean. When that happens, even perfectly normal audio ends up flagged as a misfire across the board. Different languages have a different spread of what good sounds like, so we remeasure it per language. Even with all this, the machine's judgment still isn't perfect. There are still misfires that pass the automated check, but are obviously a different voice the moment a person listens. That's why the final check is done by human ears. We built a dedicated web UI where we can re-listen to the audio line by line. The flagged ones from earlier get checked separately and get extra attention. If something sounds off, we just hit a button right there to regenerate it. We keep redoing it until we get a good one. Machines cut down the numbers, and humans handle the final listen. With that two-step setup, we prepare voice lines ready for the videos every day. Out of the 8 I tried, I never found a model that avoids misfires entirely. But if you build the system around gacha pulls from the start, character voices actually become practical.
So if you were building this today, which one would you pick?
If you're making a Japanese voice character, right now I'd recommend OmniVoice. Generation is fast, so even when you get a misfire, redoing it isn't a hassle. If you're building around gacha pulls, that speed is what matters most. In this test too, Japanese had fewer misses than most. That said, I only tested Japanese and English, so I can't speak to other languages. Also, if you want more voice consistency, there's the option of collecting voice data and fine-tuning a model. You trade the effort of collecting data and training for less variation. Our own voices still get the intonation or reading wrong sometimes. I'm aware of that too. and I only tested 8. There might be models out there that suit us even better. New TTS models keep coming out, so I'll keep testing each one and updating these voices too.
Sharina's voice might get a version update eventually too.